be some sort of elevator-ish type music for sure. It's not impossible. Oh, anyway, I'm just gabbing now because I want to, give people an opportunity to get logged in. I was late in getting started today, and I apologize. But you know what? I think, to be honest with you, you sort of knew this about me because when we would meet in our normal class, I would sometimes be a few minutes late because of a class right before it, and that kind of happened here now where today we had that same kind of thing happening where I simply ran over on that class and then had to get a couple of things in line for this class. But, okay. So there's 15 people here so far. I'm trying to think, on a typical Monday night in Bio 105, how many people would we have? I don't know. 15 might be a normal starting number. I mean, there's some people who are enrolled in this class who have just disappeared, and I've been unable to get a hold of them. And I mean, they disappeared way back when. I mean, they went out to spring break and never came back from spring break. And that's too bad because I don't know. I feel like I honestly feel like in this class, I'm doing a better job than I'm doing in my other class. And the reason is because my other class, I've got so much material that needs to be covered. It's just crazy. And I'm supposed to be supplementing that with labs, which I can't really do in those other class because this other class requires, test tubes and chemicals and microscopes and this kind of stuff. But I feel pretty good about the idea that we were able to segue into a lab that we were getting ready to start on anyway. Oh, I guess that's not true. We started on the water public hearing lab, and that's where we got cut off. We were going to come back from spring break, and we were going to meet for a couple of weeks and then do that water presentation, which that's a bummer. I mean, and that's one of my favorite labs to do. People get to, work in groups and all that to produce a water plan. And the winning water plan, I would give out like a really nice certificate to everybody in the group that I know they would stick on their walls and put it in their resume and who knows what. But not so much now. But the home ecosystem lab, I sort of think, well, you know what? You're stuck at home. Might as well analyze your home ecosystem and perhaps think about what things you might do differently in the future around your home ecosystem to produce less garbage, use less energy, use less water. I wouldn't want you to alter the biodiversity of your house. I'm sort of opposed to damaging the biodiversity no matter where it is. Anyway, well, I'm going to get started. I am recording. I am presenting. So, if you need to cover yourself up in case you accidentally appear on the camera. And Caitlin, the answer is yes, the summary sheet has been posted. And I will, in fact, we will look at it because I want everybody to understand it. I appreciate it that some people have sent me data. You're going to be kind of astonished when you see what I'm asking you for, which is just a very brief summary, and then I'm asking you some questions about what you learned. But I don't know. I don't want to see all those pages of data. I mean, I can barely. Well, no. I want to say I'm not keeping up with the stuff I have to look at now. I mean, it's going to take me until the day of whenever grades are due, working 8-hour days, just finishing up the grading. I did put a trickle of grades on D2L from Bio 105 this weekend. Not a lot, but a few. So if you've seen that things have changed there, then that's, because I was able to grade things and put a trickle of things up. But I'm constantly working on grading, and believe me, we will know what our grades are 2 weeks from tonight for sure. No doubt about it. And that is sort of interesting to mention that 2 weeks from tonight is our last meeting night. And between now and then, I've got lots of stuff that I'd like to think about and look at. But it is, in fact, 2 weeks from tonight that is our last day. So, we should have a virtual party that night. And if you want to, as I said, we should figure out what we can do that night, because I do want to meet that night. When it comes right down to it at the very end, I know that there's going to be many people. They're going to look at their grade and they're going to be, Steve, I am so happy with that grade. I'll take that A. I'll take that B. Even people will say I take that C because all I need is a C to move on. And so many people will be really happy with their grades. But if somebody is unhappy and we need to figure out why, then I will have individual meetings with people. I have individual meetings with students periodically. And so if that's what it takes, then that's what we will do. We will get it all done. But believe me, those people who are here and they are participating to the degree that they're participating now, those people are on my short list of people who deserve good grades. So, keep coming to class, do the best you can on the things that I'm asking you to look at, memorize every word in those PowerPoints. I'm only kidding. Why would you need to memorize that? And as I said, I've got documents and things that I want to talk about tonight, of course. So anyway, that is the plan for, that's the plan. We're going to be done in 2 weeks, and people will be able to move on and do whatever they're going to do next. And I'm hoping nobody needs to repeat this class, unless it's somebody who just dropped out, and didn't even come back from spring break. Oh, that's not that abnormal. I always have some students who they go away for spring break and then they decide, forget it, I'm never coming back. I am sick and tired of going to school. They've got spring fever. They don't want to look at me again, which I totally understand. And then they they just never come back. But it's a little worse this time around because because of the virus. I think there are people who were enrolled who just decided, hey, I'm going to move back east or whatever and take care of my parents, but I'm going to give up on school. But as far as school goes, I know that they are working hard to try and figure out exactly what they're going to do in the fall. They did, in fact, push the registration back, so that fall registration begins on the 25th, which is 3 weeks from today. So they pushed it back, 3 weeks? 3 weeks, yeah. They pushed it back 3 weeks because they originally were scheduled to do it now. But honestly, there's some pretty smart people at Pima College who are trying to figure out what to do next. Not including myself in that list, but some pretty smart people there who are trying to figure out what to do with summer classes and fall classes and how to make it work and how to help students, achieve their goals and stuff. But we live in crazy times. Crazy times. I don't really know what's going to happen in the state of Arizona. I know that every day I check and there are more cases in Pima County and all that. I think that we are nowhere near seeing a peak anything like that here in Tucson. We are absolutely in the very beginning. If it's going to go exponential, we're in the arithmetic phase now. It hasn't gone exponential yet. And it could go exponential here and could have many, many people hospitalized. We just don't know that. I think we're a little bit lucky. Well, to be honest with you, I think we're lucky to live in Tucson, Arizona anyway. I was born in New York and lived in the East Coast for, the earlier years of my life, and I would never move back there. I would stay out west, where I think we do more social distancing than they do back there. We don't ride subway cars that are packed like sardines. We don't walk down streets that are packed like sardines. It's simply just not what happens here. The density of people is lower, and the kind of transportation that people have to ride on a daily basis, well, let's face it, most of us drive a car. A few people ride the bus and a few people ride the trolley. There's no subway system that packs people in like sardines, which really that's what it's like in New York. They pack those people in. You literally have one more person will try to squeeze in before the door slams shut, and then people start coughing and hacking and whatever. That seems like the perfect breeding ground for an infectious virus like COVID-19. And we don't have that out here. So, I mean, I'm not saying we should, completely relax our diligence now. If you opened a movie theater tomorrow, I wouldn't go to a movie theater packed full of people. I wouldn't do it. But then there were people who would, and maybe they've already had the virus and their immune system is just ranked up. Anyway, where am I going with this? I'm just wandering on and on. But so let's do something more productive. I'm going to go over to I don't know why this thing is up here. I'm going to go over to a PowerPoint. Here it is. Oh, there's those green onions. Let me shrink this down a little bit. This is, I hope you recognize this PowerPoint. Oh, let me view it correctly. Hope you recognize this PowerPoint because there's the green onions growing and being harvested. But I'm going to go to the second.
Excuse me, Mr. Mackey.
Yes, good morning.
Hello. I think you turned off your presenter mode because we can only see you now, not your PowerPoint anymore.
What a bummer. Okay, here I go. Yeah, I was presenting. Who knows what happened to it? It's still recording. Maybe I'm accidentally clicking on it. If I am, that's crazy because I try to be kind of careful about what I click. But anyway, here we come back, I hope. Here I am presenting, it says. So let's go over here. And now can people see this? Would somebody just reassure me? I can see this coronavirus lecture 11.
Yes.
All right, excellent. Thank you. So let's take a look at this. Remember, the first page in this document looks like this. This is document number 0018 called Soil and Food PowerPoint. We're mostly done with this document. I just want to finish it up. A few more pages that are left that I want to go through. So let's just look down at this list. This Soil and Food PowerPoint posted as document 0018. The Biodiversity PowerPoint that I'm going to get to tonight is posted as document number 019. YouTube posts are searchable now. I really think I've already posted the last lecture up there. If somebody checks and they don't find it, let me know. Then quiz number 17, which is posted as document number, wow, that's weird. I made a mistake here. This says, I'll correct it. But so quiz number 17, the population planning one, it was technically due right today now, and it's posted as document number 0017. And what was the mistake I made down here? Oh, I see.
Oh, they're both the same.
So, yes, go ahead.
They're both the same.
Yeah, that's right. And that was a mistake on my part. Thank you. I'm going to correct this. I can correct it because it shouldn't say that. It should say quiz 18, which is soil and food, is due Wednesday, May 6th, and it is posted as document number 0020. Okay. So make a note of that because this has already been posted and now I've made a correction to it, but I'll do my best to make sure I get it reposted. But quiz number 18 is posted as document number 0020, and it's soil and sustainable agriculture and the pesticide treadmill and all stuff that you should be able to get good answers from if you are listening to me, or if you want to go back and listen to my entire lecture, you can. But otherwise, I would look at that PowerPoint. All right, and that PowerPoint is the one we're looking at right now, where the answers to the quiz number 18 are mostly to be found. Okay. Tonight's topic is soil, food, and biodiversity. And the ecological footprint assignment is due last time. I just decided to leave that there. And then home ecosystem stuff, lab stuff too. I know everybody is carefully gathering all this wonderful data on your home. And guess what? Here it is, the summary sheet that I promised you, document number 0021, is due a week from today. So while we're thinking about it, let me find that document and show it to you so we can just talk about it now. It's here somewhere. I'll find it. Sorry, I should have had this already done. All right, jump away from here, and I'm gonna push this over to the side. So, you know, of course, people have been collecting lots of great data, and I would have collected all those data sheets, and I probably would not have looked at them, right? I mean, I would have collected them, and if they looked like they were filled out right, I would have given you full points for them. But the truth of the matter is that, that in the new mode that we're in here, I thought it'd be best to just, you know, do a summary sheet that people could fill in. So if anybody has any questions about this, of course, you're going to jump right in and you're going to ask.
Yeah, I have a question.
Well, I haven't even talked about it yet. But go ahead, though.
Like, how do you convert into percentage?
Oh, okay. I'd be happy to talk about that. So let's, I'll show you that. We'll talk about percentages in a minute. But first, let's take a look at this data sheet, okay? This is where you're going to summarize all your data. It's 2 pages long. That's it. And it has a section on water and some questions. It has a section on energy use and some questions. It has a section on garbage production and some questions. And then it has the section on biodiversity and no questions, just data. I mean, because you're basically answering some questions about the total number and the percentage of total and all that. So, you know what? Let's go to this area right here, okay? And so you can see that there's a section for you to summarize your data on every one of these categories. But let's take a look at this summary sheet right now. And because this is my document sitting right in front of me, I can write some numbers in it. So I'm just going to make some numbers up, okay? Hold on. I'm going to save this as it is, and then I'm going to not save it later, okay? Total bathroom. I'm just going to make some numbers up and say, okay, in the total bathroom, it was 40 gallons a day. Total kitchen was 35 gallons a day. Total drinking was 3 gallons a day. Total outdoor use was 0 gallons per day. Okay? Everybody following me? We've got, am I presenting? I'm presenting. So I've just filled this data in just like you would. Now, how do we get the total water use? 40, 75. Oh, wow. Why couldn't I have chosen some easier numbers to use? Let me recorrect this. So let's say that that this is 40 and 37. All right. I did that just so it would add up to a nicer, easier number. 40, 37, and 40, 77, 80. The total gallons used per day was 80. All right. Does everybody see how I got those numbers? First, I made those numbers up. That's all. So now, so we've got 40 gallons in the bathroom, 37 gallons in the kitchen, 3 gallons in drinking, no outdoor water use. Total is 80 gallons per day, okay? Now, in order to calculate the percentage, you're gonna do it over here like this. You're gonna have 40 divided by 80 equals Well, 40 divided by 80 is 50%. Here, you're going to have, oh, sorry. You know what? I sort of did that not quite right, all right? And here's what I mean. Is when you actually do this, it's going to look more like this. And let me just show you what this is going to look like. I think I'll reduce this for a second, and I'm just going to pull up a blank document. Oh, I guess I could have done that. I want to get a blank document for percentage calculations, okay? We're going to call that this, percentage calculations. Right, so here's the thing. Remember that first example? 40 gallons in the kitchen divided by 80 gallons total. This actually equals 0.5, right? So then what you have to do is multiply it by 100 times 100 equals 50%. So just for the record, that's what you really have to do. You have to, you're going to take this number, 40 gallons of water in the kitchen, divided by 80 gallons. 40 divided by 80 is 0.5. And then you multiply that by 100 to get the percentage. And 0.5 times 100 is 50%. Okay? I mean, I've done this so many times that I just forget that 40 divided by 80 is 0.5, and I just go, well, that's 50%, right? Let's take another example here, right? Let's go let's do the what was it? Was it kitchen that it was 40? No, that was actually bathroom, wasn't it? Why didn't somebody tell me that? 40 gallons bathroom, okay? Divided by 80 gallons total equals 0.5 times 100, or 50%. 50% is used in the bathroom. Okay. All right, now, what about that other one? Because the next one was 37 gallons per day divided by 80 again, because 80 is the total. Okay. And then, so 37 divided by 80, oh my gosh, I need a calculator for that. Does somebody have a calculator out there that they could grab onto really quickly? Because this is
Pablo.
Hi, Pablo.
It's like 46, like 46 point something, but rounding 46.
So it ends up equaling 0.46 something.
Yeah.
Is that what it is?
Yep, like 0.25, yeah.
Okay, 4.4625. Let's just round to 3. And then remember, we have to multiply that by 100 equals 46.3% in the kitchen. Now, some math major, jump in and tell me how I screwed this up, please. 37 gallons per day divided by 80 equals 0.463 times 100. When you remember, when you multiply by 100, what you're really just doing is you're taking that decimal point there and you're hopping it 10 times 10 or 100. So it's 46.3%. Now, here's the thing. 50% plus 46.3%. Whoops, I should have been not equals. Plus 46.3% equals 96.3%, right? Now, whatever's left, the other one that's 3 gallons, I got to tell you, the 3 gallons it's all going to add up to 100%. So the difference between 100% minus 96.3% equals 3.7%. Right, so now we've got bathroom, kitchen, and just by sort of reverse engineering it, we realize that drinking water has to be this. These always got to add up to 100%. So 50, 96, and then 3.7, there you go, 100%. And there, I know there's a little bit of rounding error there, but we got it basically set up. Now, Carol, was this understandable to you? Because you were the one who asked about this.
Yeah, now I see. Okay, thank you.
Hey, you're welcome. I'm going to save this down in case there's questions later. But so what did we discover here? Well, we discovered that this was 37 divided by 80 equaled
4.4.
this one was 37 divided by 80 times 100 is 46.3. Okay. And then, like I said, if there's only three things, then this 3 has to be 3.7%, because all of this has to add up to 100. 50, 96, 3.7, excuse me, adds up to 100. And then I was asking you to look at your data and answer this question. What single activity uses most water? Well, that is, you're not going to get that question from here. You're going to get it from looking at your actual data. And so, you know, you're going to look at your house and go, you know what, I've gathered all this data. I'm going to use the thing that used the most water was filling my swimming pool, whatever. And then list 2 things you could do to reduce water use in the home that would not be too inconvenient. Okay. Next is the household energy use, and this data, same basic thing, right? We've got the energy type, which is electrical, gas, solar, or other. Maybe you're going to tell me about something else I don't know of. And then you're going to remember we had the total energy consuming devices or appliances, right? Well, let's again do another example. Let's say that the total was 20. You had 20 different energy consuming devices or appliances, okay? And that 14 were electrical. 14 divided by 20 equals 0.7 times 100. Equals 70%, right? So 70% of your energy use is electrical. And then you're going to do the same thing here, right? The total was 20. So you're going to take whatever this number is, gas, divide it by 20. You're going to get a number like 0.7 or 0.01. You're going to multiply that by 100. It's going to give you the percentage, okay? Now, the next line is, this was just about, you know, the energy survey that you did. Then you're going to tell, okay, how many actual light bulbs did we survey? So, so I don't know, let's say I had 12 light bulbs, and incandescent bulbs were 4 of those, and compact fluorescent bulbs were 4, and halogen bulbs were 0, and LED bulbs were 4. Right? Oh, that's interesting. Or 4. That's all you're going to put in. This is your actual house light bulb data count. And remember the second part of this, I asked you to do it with all LED bulbs. And so, oh, by the way, sorry, let me go back. Now, this total kilowatt month for all of these bulbs, this is data you're going to get right off your sheet. What did you calculate? So let's just say, for what it's worth, that that you calculate out it was 35 kilowatt hours per month. And remember, a kilowatt hour costs 10 cents. So 10, there's 35 times 0.1, not times 10, but 0.1. So all of those bulbs cost you $3.50. I know I'm screwing with this, but when I go to save it, it's just gonna, all of that's just gonna, all these alterations are gonna disappear. Now this one is interesting. The total carbon dioxide produced. Well, here's the thing. Light bulbs don't produce carbon dioxide. I don't want you to think they do. But when you plug in a light bulb and you ask the electric company to deliver electricity to you, that electric company is very likely to produce carbon dioxide. Now, it used to be that whenever you plugged in a plug to get electricity in Tucson, it definitely came from a coal or natural gas burning power plant. You know, we have one of the biggest nuclear power plants in the world, I think. Well, certainly in the US. It's up by Phoenix. Believe it or not, we don't use any of that electrical power in Tucson. In fact, I don't think they use much of that electrical power in Phoenix. I think it almost all gets purchased and sent over to California. Anyway, so we get to deal with the waste and the potential problems of a nuclear power plant, but all the electricity goes to California, probably pretty cheap too. Anyway, sorry to get off track, but the bottom line is if you take this 35 and you multiply it by 1.5, it's going to tell you the pounds of CO2. So it's 35 kilowatt hours times 1.5. That's 35 times 1 is 35 plus 17.5 is 52.5. 2.5 pounds of CO2 that were produced. Right? Now, in this all light bulbs, remember the second part was I said, look, pretend that every light bulb in your house was an LED bulb, and then tell me what the kilowatt hours would be and what the total cost would be and what the carbon dioxide would be. So the bottom line is that, like I said, for that one page, you're going to go and say, all right, I'm going to pretend that these are all incandescent bulbs, no compact fluorescent bulbs, no halogen bulbs, 20 LEDs. And what kind of difference did that make in my monthly cost and in the number of pounds of CO2 that I produce? Was there a question out there? I heard somebody cough. I didn't know if they were just trying to gently interrupt me, which is fine. Don't gently interrupt me. Just jump on in and say, Steve. Okay, so these things are a little bit messed up, but this is basically what you got. So then there was garbage, all right? Oh, it is asking you about 2 things you could do to reduce energy in your home that would not be too inconvenient. Here's garbage production. This is pretty much a copy of everything. So again, down, ooh, I know. What I should have had down here was another line that said total garbage reduction in gallons, right? So that is a correction that I should make. This line here should be total. Oh, why am I even writing this down? I'm gonna end up erasing it when I hit don't save. Okay, but I'm gonna go back and modify that document. Sorry, because this should have total garbage production. So you have a total volume here, 300 gallons, and then you can go back and calculate out the percentages for everyone here. And then remember over here, this percent recycled is basically telling me, look, what percentage of this particular type of garbage do you recycle? If you don't recycle anything, then this is going to be zeros, just straight zeros, right? But, you know, in my house, for example, newspapers, they get 100% recycled. Other paper, probably about 30% gets recycled. Aluminum, which is aluminum cans, 100% recyclable. Other metals, more like 20%. Glass, maybe 10% gets recycled. Okay, and so the bottom line is that I actually, you know, I've got one of those blue containers outside by the street, and we tend to recycle a lot of things. But, you know, somebody's asked me, well, Steve, why don't you recycle 100% of your glass? And I'll tell you why. Is because if you recycle glass, you're technically supposed to, wash it out and take the label off and do a bunch of work to get it ready to recycle. And I wonder, well, what's more valuable, glass or water? Because it might take quite a bit of water to wash these out or to get that label off. What's more important, glass or water? And my answer is I think water is more important. Now look, you know what they make glass out of? Sand. And if you drive between here and Phoenix, you're going to see enough sand to construct a globe of glass over the entire planet, just about. So, you know, glass, you just melt some sand to make glass. It takes energy. Maybe it keeps people employed. But when you use a bunch of water to wash it out so it can be recycled, that seems like a cost that I'm not necessarily wanting to address. Anyway, it's so you could ask me, and I think, well, there's reason. And then I have to admit to you, and I'm really sorry that we're not doing presentations in class, but I don't even understand what's going on with our recycling these days, because I'm not 100% convinced that we're actually recycling. I mean, I know the truck comes along and picks up the recycling. Oh yeah, I know it does. But I think most of the time now, it takes that recycling to the landfill and just dumps it in. And that's sad, but the reality is that that a lot of our recyclable materials used to be purchased by China. And China's just not that happy with us right now. And I think they basically said, you know what? We don't want your recycling anymore. And so the recycling has just accumulated and accumulated. Now, again, I wish somebody would Google this and tell me, Steve, you are totally wrong. But I don't get a good sense about the recycling system that we have now. Oh, aluminum cans? Well, I don't think those end up going anywhere. I don't think they send those to you recycle aluminum cans. However, let's just say in your recycle bin, you've got 50 aluminum cans, but then somebody throws a pizza box that is all greasy and nasty. Well, that spoils the entire recycling container. And so they may just decide, oh, look, somebody threw some non-recyclables in here, so we're just going to dump this whole thing, cans included, in the landfill. And I'm totally happy when somebody walks down my street and goes through and collects the 300 cans of soda that I drink every day and takes those and recycle them, because I'm happy about that. But when a load gets spoiled because somebody puts something in there that isn't technically recyclable, but people do all the time, they put styrofoam in. You can't recycle styrofoam, not in Tucson. They put, nasty stuff. They put even pill bottles. You can't recycle pill bottles in that. They don't want those. And once they see pill bottles, they just take what's there and they just dump it in the landfill. And you think, why did I go through all that recycling problem? Well, anyway. I hope, if I'm wrong, please, somebody figure out that I'm wrong and tell me I'm wrong. All right, then, so we've got the garbage production, pretty straightforward. And then here's household biodiversity. And, it isn't spread out over 2 pages like this. This is just because I've written on this page. But here I'm asking you to tell me the total number in each kingdom and the percentage of total. And that's it. Okay, so I'm going to do this. Well, first I'm going to ask, can I explain the whole percentage thing again to anybody? Again, I'm going to say, if you were to go to YouTube and you were to put in the YouTube search line, how to calculate percentages, you get like 500 math teachers telling you how to do it. And I'm not a math teacher. I can barely do math. But the bottom line is, if you have questions about that, you could text me. Sorry, you could email me, or you could go and check it out on YouTube. And now I'm hoping when I go to close this, it says save changes and don't save changes, right? Because now I don't really think I need this anymore, so I don't need to save that. Then the summary document, the summary document should be unblemished, except for the one thing that really does need to be changed in it, and I apologize. It's, come on, where is it? 0021. When this reappears, aha, nice. But the thing that does need to be changed is down here. I don't know how I figure this out. Total garbage. Okay. So I hope I remember to post. All right, so that's going to be your total garbage down here. Now, this I do want to save because that should have been there. Can't calculate out the percentage without the total number, okay? Hey, before I go away from this document, is there anybody who has any questions about it? This is due a week from today, and you know, I really appreciate everybody's hard work in collecting these data around their homes. I really do. But I don't want to, I mean, you know, you've just generated multiple pages, and I want to see the summary, and I want to see the answers to your questions. And so that's why I produced this summary sheet. Okay. Any questions about it? Better look to make sure I can actually see if there's any questions about it. There I am. Okay, look, I see chats. So let me just summary sheet. Oh, is that true? Is marked at quiz 18, not 17. Really? So that messes with my mind, because quiz 0017 is the human population czar, but it says 18. Is that what it says, Lisa? The quiz that is due tonight is marked at quiz 18, not 17. Is that? Anyway. Okay, well, thanks for telling me that. Let me look at that document real quickly. Okay. You know what? They should, this whole, trying to keep track of all this. It's so much easier in class. I could just say to everybody, hey, change the number on that. But I guess that changing the number on it is, well, I mean, it's something that you can do for me. I would appreciate it. I'm going to try and keep track of it. So it's, it is quiz 17. It says quiz 18. I got it. It's not going to let me correct this. I'm going to have to do this. But is everybody paying attention? Would you make sure that the quiz where you are the population minister is actually quiz number 17? You've already sent it to me. Don't worry. I'll figure it out. I'm not real stressed out about that. But I do appreciate you pointing it out to me. I really do. And then, okay. So we're going to go. Not there. We're going to go to here. Okay. And I'm going to ask one more time. Is there anybody who has any questions about this summary sheet? Because this summary sheet is worth quite a few points, actually. So you want to make sure that you fill it in as accurately as possible. Believe me, though, it may be, again, that your total outdoor water use is 0 gallons per day. That's entirely possible. Then it's going to be 0% too. Now, I would be astonished if somebody didn't use any didn't live in the, if they did use any water in the bathroom. That sounds impossible to me. Maybe you have an outhouse outside and that's it. I don't know. Anyway, all right, I'm closing this. And so here I am back. Okay, so I've got 2 different PowerPoints tonight. And I'm going to go to this one again. So I did post a brand new quiz today. Like I said, it's quiz 18 on soil and food. And I know we're not done with that material, but that's okay. It's not due till next time. And then we're going to finish the soil and food PowerPoint and then go into biodiversity. And if anybody, of course, has questions about the Home Ecosystem Lab stuff, I'd be happy to address that. But, we've been talking about that for a while. I think this is okay. Now, go back to make sure we're reading it correctly. And I'm going to make sure I'm still presenting. Yes, I am. Okay. Soil. Lots of information about soil. We went through this, ways of transitioning from industrial agriculture to sustainable agriculture practices. Here we were. This is about where we ended up the other day. And so I want to say it again, sustainable agriculture techniques can keep farm productivity high. Now, look, if you've been running an industrial style agriculture system, when you try to switch over to sustainable agriculture, it's going to be a little bit painful because it's challenging. But the bottom line is that if you are using an industrial style of farming, you are going to are eventually going to damage your soil so it doesn't grow as well. You're going to use so much water that you're going to probably run out of water. You're going to use a bunch of pesticides, and that's going to poison your soil and cause the pesticide treadmill to happen. And so, it's great when you do industrial type farming like this, you're basically deciding, hey, let's farm for 10 years, and then we'll go farm somewhere else, right? But when you do sustainable agriculture, you're deciding we're going to farm forever. We're going to farm forever because sustainable means forever. Now, there's things you're going to have to do sustainable farming. You're going to have to use much less pesticides, maybe none. So maybe you use natural predators. So you're going to set up a system that uses less water. You're definitely not going to use bags of fertilizer that you just pour on your ground. You're going to use fertilizers like what they call green manure or brown manure. Brown manure is exactly what you think. It's cow poop, horse poop, pig poop, goat poop. That's brown manure. In some parts of the world, they use human manure as a fertilizer. And green manure is plant parts, so leaves and things like that have been composted perhaps so that they are big fluffy fertilizers. Those big fluffy fertilizers, whether they're brown or green manures, they keep your soil richer and less compact, and they provide nutrients in a more natural way. So I'm not going to go through every one of these with it, the advantages and disadvantages. I mean, it is true that the advantage of sustainable agriculture is that you're not going to use insecticides. You have less potential for water pollution. You have more genetic diversity. But bad things is it requires more people. You may not be able to grow all crops in all areas, but I think that's true with industrial too. Other advantages that there's less risk of exposure to antibiotic-resistant bacteria. The animal products you produce don't have hormones. It's better taste, I have heard. I mean, I buy organic food and I taste it compared to inorganic food, and I have to tell you, I don't have the best taste buds, I guess. The disadvantages is that it's more expensive. So you really need to be aware that it's complicated and that you're going to have to learn a new system of agriculture. So into the future, the Green Revolution 2, well, of course, one of the things in the Green Revolution 2 is the idea that genetically modified crops may help feed the world. And I know people, there are people who are really concerned and worried about genetically modified crops, and I think there are ones we do want to be concerned about. But you know, human beings at one level have been genetically modifying agricultural crops as long as we have harvested crops. We've been genetically modifying them. Now, that may be in a way that isn't quite as technically sophisticated as what we did now, but if you could see what the original corn plant looked like, and you know what, I think I'm going to try and show you, because I think I can find this pretty quickly, and I can find this pretty quickly and show you it. It's pretty amazing, really. I mean, I love corn. I like corn on the cob, and so I love to eat corn. I just think that that the original corn plants that were genetically modified look so dramatically different than the current corn that we eat now. And I don't know, I'm looking at a bunch of these, but this one's, let's see, the teosinte, this sort of original corn, it looked so radically different, okay? And so, I don't know, this picture will work out fine. I think this one will work out pretty well. Come on, open up, you. So look, take a look at this image. I'm assuming everybody can see this image. On the left, here's what the original corn looked like. That was essentially prehistoric corn. Here's sort of a representation of what corn looks like today. Now, this was done by genetic engineering by humans. Humans looked at this original corn. There was some kernels on it, but then they started selecting, you know, they did artificial selection and they started generating bigger corn, better tasting corn, etc. I mean, just amazing how much different it is. I mean, there was another document down here I really liked. Where was it? Not that one, this one. There's a document that they showed down here, sort of like the evolution of corn. And where was it? Here it is, right here. Well, yeah, not very easy to see. But here's the little stubby corn. And then it was genetically modified, and now look at this. We've got this great hybrid corn, gigantic, and I don't know what's going to happen here, but anyway, bottom line is that this is a kind of genetic engineering. It's genetically modified corn, let me tell you. And but it's not quite genetically modified the way that this particular document is showing, where it basically shows that that they are adding genes into the DNA of corn, okay? And the genes that they are adding in are genes that can produce their own insecticides that are genetically produced. So there's no doubt that genetically modified crops could help feed the world, no doubt about it. You can use genetically modified crops to make them more nutritious. You can increase their resistance to pests or droughts, all kinds of cool things. I mean, it's true, in the United States, more than 75% of processed food contains genetically modified organisms. Elsewhere in the world, consumers have been very assertive about keeping genetically modified food off their shelves. Well, there's reasons for being concerned about genetically modified food. People can be allergic to genetically modified food, but people can be allergic to non-genetically modified food. It is possible plants can actually transfer some genetic resistance to other nearby plants. I don't understand that a lot, but over time, that can cause problems where the genes for pesticide resistance get passed on to other plants. Uh-oh, what did I do there? So genetically modified crops, you can take a look at this. So let's talk about food and feeding people. There was this very famous economist, really, who way back in the 1700s, Thomas Malthus, he said, look, population's increasing exponentially, but food resources are increasing linearly. This is a big problem. And you look at this graph and you see here's population growth and here's food growth. And that is a potential big problem. Why? Well, because we're gonna run out of food if the population continues to grow. Now, he couldn't anticipate the Industrial Revolution, the Green Revolution, pesticides, all that stuff that allowed us to massively increase the production in agricultural regions. But there is this question, I mean, have we maxed out the gains from the Green Revolution? World grain harvest has been increasing the time, but production per person has leveled off. The area under production has leveled off. I mean, it's not like you can grow things anywhere, right? So there has been a decline in the total production. So the real question is, will we be able to supply enough food for everybody in the future? And it depends on a couple of different things. One is the rate of population growth. I mean, I don't know. Right now, I was watching the nightly news last night, and there are some big famine events happening right now, like record-breaking famine in some countries. It's not related necessarily to the population growth, though often these countries do have large populations. It could have to do with climate change and drought. It could have to do with food delivery systems, which here in the US even, we're worried about food delivery systems. I noticed the other day I was in the grocery store and there were limits on how much meat you could buy because the food delivery system in the US is stressed out to the max right now. So how do you make more food available to the world market? Well, one thing you can obviously do is put new land into production, right? Another is you can try and increase the yield on the land that you already have. And lastly, you can improve the use of existing food supply. I mean, really, we throw away a ton of food in the US, especially. We throw a ton of food that just ends up rotting. We don't even turn it into compost. So put new land into production. Well, unfortunately, most of the land that isn't in production isn't in production for a reason, right? The bottom line is that there's people who are saying, look, we've used all the land that can be used for agriculture and food production is already being used. And in fact, some of the best land for food production has been converted into malls and parking lots and cities and roadways, etc. You know, I can picture a time when there was a little city and it was surrounded by farmland. You know, in Tucson, Arizona, that probably was the case. But as the population of the city grew and the fringes of the city grew out and grew larger, agricultural land was sacrificed for the purpose of continuing to build the city and doing urban planning, etc. So how do we make more food available? Well, one was to increase yields. Like in the Industrial Revolution and the Green Revolution, all of this has increased our yields over the past 150 years, but we're maxing out on pesticides, fertilizers, irrigation. I mean, there's the story of Tucson, Arizona, where lots and lots of water was pumped out of the aquifer and put onto local farmlands that made for more food and encouraged more people to come here and all that. Well, guess what? Where's that water now? I mean, Warner's Lake is gone. The river that ran all year long is gone. We worry about other We worry about communities forming that take a certain amount of water. I mean, the bottom line is that there are parts of the world that have been the parts of the U.S. that have been the bread baskets for the growth of population in the U.S. that now are really struggling. I mean, in California alone, huge amount of food grown there, big water problems. Maybe they're a little bit less bad right now, but they are definitely, they haven't gone away, because as climate changes, which inevitably will, it's going to dry out the Western U.S. and suddenly it's going to be harder to get water. And those places that used to provide a lot of food are not going to be able to do it. They're just not going to be able to provide the same amount of food in the future that they have been historically providing in say, California for the last 50 years or more. The last one, of course, was improve use of existing food. And really, the number one thing, we've talked a little bit about this before, is that we should feed lower on the food chain. I mean, 90% of all U.S. grain is fed to livestock. Now, look, I like meat. But would I be willing to eat less meat to make sure that there was more food available? Yeah, sure. People don't need to eat meat every day. They can, I know many, many very healthy vegetarians. I know people who are not vegetarians. They wouldn't identify themselves as vegetarians, but they eat a vegetarian meal 4 days out of 7, and then they reserve meat, whatever their favorite meat is, to for 2 or 3 days a week. Again, you know more about this than most people, because you know about the rule, the 10% rule. If you have 1,000 pounds of grain and you feed it to a cow, you're only going to make 100 pounds of cow, because 90% of the energy is going to be lost in the pure energy of ecosystems, which you understand. You could develop better food preservation techniques, because we lose a lot of food because foods go bad. You could improve the use of existing food supply, distribute food better. You could make sure that if there are areas where there's excess food, that somehow that food gets diverted in a useful way to people who do not have excess food. I mean, of course, now, again, I can't help but think about the news where there's, mile-long lines of people trying to get food because they don't have a paycheck coming in, and the food system is breaking down a little bit. So, improve the use of existing food supply. We feed lower on the food chain. We eat more grains ourselves. We develop better food preservation techniques. We develop better food distribution. We educate people so they have improved nutrition, and probably as a result eat less and eat better and are healthier. So another thing is we need to diversify our food sources. I mean, the bottom line is that we kind of eat a limited number of things, okay? A relatively limited number of things. All right, look, sorry, it's 7:02 and I've just been plowing away at this. It's making me hungry. But let's take an official 10-minute break, okay? Can we do that? Be back at 7:12, and I'm going to run a couple of short videos. So, you might want to get something to munch on while I run these videos so you won't be too hungry. All right, this is, all right, 10-minute break.
Switch to Sprint to get our best unlimited deal ever. 4 lines of unlimited for just $100 a month. If that's not enough, we're throwing in 4 Samsung Galaxy phones on us. Shop from the comfort of your home at Sprint.com. Call 800-SPRINT1 or come see us in our stores. Phone after 30. 18 months credit apply with 2 bills at the end of the basic after 7/31/21 pay $35 per month per line without a vacation. Prioritization during congestion coverage and offer not available with more access fees and local speed maximum use rules. $30 activation fee and restrictions apply. AccuRadio is made by music lovers for music lovers.
Okay, folks, sorry, I'm back. Sorry, I got to show you this video. I pulled up a couple of interesting videos that they're pretty short. But we're talking about food production and all that.
After my DVT blood clot, I wondered, could another come around the corner, or could it play out differently? Eating insects could help fight world hunger. So why don't Americans eat bugs? 2 billion people worldwide regularly eat bugs. That's more than a quarter of the entire population of Earth. And
Mr.
while
Mackey?
Yes. Uh-oh.
Are
Let me
those-
look.
Okay.
There we go. Thank you.
No.
But a handful of people are trying to change that, including Jared Golden. His company, Entomo Farms, started selling insects for human consumption after the UN released a paper on the individual and global benefit of eating bugs. They sell things like cricket protein powder and flour, whole roasted crickets, even seasoned cricket snacks.
But to produce the same amount of protein, crickets take way less water than it does to produce that protein from beef, much less land. And there's a lot less methane gas produced from the crickets than other traditional forms of livestock.
Pound for pound, crickets have almost twice as much protein as beef, and some edible insects have even more.
There is a way for us to provide our population with a safe and eventually cost-effective method of getting protein. And protein is key.
By 2050, there will be 9 billion hungry mouths on Earth, and the already high demand for livestock products is expected to double from what it was 20 years ago. But not only is beef expensive, cows couldn't care less about the environment. Manure contaminates water supplies and emits ammonia that harms ecosystems. And 70% of previously forested land in the Amazon is now pasture. Bugs don't contaminate or require nearly as much water or use that much land. So what's the problem? Americans don't eat bugs because Americans don't eat bugs.
You like lobster? I do. I love lobster. Years ago, that was the garbage, the cockroaches of the ocean. And all of a sudden now, it is phenomenal food.
The key to transforming lobster into a luxury food was rebranding it. So who says insects are any different? We tried to change minds on a smaller scale, by feeding crickets to our team.
We got our hands on some of these bags of cricket powder. We're going to add it to muffins and pancakes. See how that tastes? This really is a superfood. How many crickets? I think one of these small bags is about 1,000 crickets. 1,000 crickets? Yeah, for 4 ounces. Yeah. Just trying to figure out which one is the least gross. Well, they're all food. They're all like edible pieces of food. People around the world eat crickets all the time. They look like such terrible American. Actually eaten a lot of bugs, whether it was like traveling and tried out this entire tasting menu. Every single dish had a bug from it to giant Japanese hornets.
We don't ever see a day that insect protein will completely replace meat protein. That's not the goal. The goal is to give people a choice that is healthy and nutritious as well as sustainable.
Well, first I just thought that they were freckles, very unattractive blob things on my face. Makes me feel like a Dalmatian. All round, brown craters.
These are actually
All right, so back here. Oh, I forgot to bring some insects to munch on. Let me show you one more. I think I want to show this one too.
Here in central Yaoundé, Cameroon, traders are selling some of the region's most prized delicacies. Depending on the season, grasshoppers, termites, or in this case, larvae of the palm weevil beetle, line the store.
Mr. Mackey, does this one have captions?
Thanks.
Manger les insectes, c'est très nutrition. Donc, ça nourrit le corps et ça n'a pas de graisse et ça ne nuit pas au corps. C'est un truc que si un être humain mange ça tout le temps, peu de rare qu'il aura des maladies.
Insects make a positive contribution to diets here, as they are packed with protein, vitamins, fiber, and minerals. And it's not only their contribution to local diet that's important to them, they're also providing earning opportunities. Here, in the forest surrounding the village of Jane, it's the grasshopper season. Philomena Inama is collecting grasshoppers, along with other women from the village. Some of them she cooks to feed her family of 7. The rest she takes to market for sale.
Les insectes sont bons parce que quand on n'a pas encore eu les produits chiants, ça va nous aider à vivre. Comme ça, on prépare, on mange. De l'autre, on peut vendre. Donc, ça nous aide vraiment.
In the height of the season, one woman may collect 4 water bottles full of grasshoppers, which she will sell for the equivalent of 15 euros in one day. The role of women in collecting insects is very important, since in many parts of the world, women are responsible for ensuring that there is food on the table to feed the family. Until recently, insects were considered an inexhaustible resource. However, human population growth has led to over-harvesting of certain species, while forest fires and habitat degradation due to unsustainable logging has brought some species to the brink of extinction.
The rearing and domestication of insects can help the conservation of wild insect populations, while simultaneously contributing to livelihood and food security. Insects have a huge potential for both feed and food. We're already seeing developments in terms of using insects as animal feed, and also being incorporated onto menus and into processed foods. While we won't be seeing insects on the table of a Sunday lunch anytime within the next decade, we know that insects have a huge potential, and we hope that slowly but surely this can be realized.
Population growth, urbanization, and the growing middle class are all contributing to a growing global demand for protein. Insects contain high levels of essential nutrients and vitamins, as well as high protein content comparable to meat products. It's hoped that insects will be considered a viable supplement to human diets, not only here in Central Africa, but in many other parts of the world.
Well, you know what? You can buy insects to eat here in Tucson if you wanted to. I've seen packets of different kinds of insects at Summit Hut. People will, like spicy different, spiced crickets and spiced grubs and that kind of stuff. The bottom line is that this is just an alternate source of protein in a world that is needing, more protein, I think. The bottom line is that I don't think that in the United States we're quite ready to eat insects, but you can. I mean, you can buy insects, like I said, in Tucson if you want to, and eat them. And honestly, it's kind of amazing, really. They're tastier than you think. Anyway, I just decided I just had to throw that video in. We're talking about alternative ways to eat. Did you see those tacos that guy was eating? I mean, it looked to me like it had tacos and onions and maybe a little bit of lettuce and some, I don't know, grubs of some kind. I mean, I would taste a taco like that. I don't know whether I would, be interested in eating nothing but bug tacos. But, and also I noticed that they again and again showed people eating scorpions. So you could go right outside and get some scorpions to eat. That would be no big problem, I don't think. Anyway, just no pun intended, but food for thought. Okay. Any questions about this PowerPoint packed full of stuff? And I know you're going to want to watch those insect videos again and again. So those links are posted there. All right. Okay. Any questions about any of this? I'm looking to see if chats are just people just saying, oh, disgusting, I'll stick to meat. Well, good luck now that meat processing plants are closed, but hopefully there will continue to be meat out there available. But reality is that when you eat meat, you are contributing to climate change. You are eating higher up on the food chain. I mean, again, I happen to like meat, but I feel like I grew up in a family where, you know, every night it was a big meat production and lots of meat every day, 7 days a week. Bacon and sausage for breakfast, processed meats for lunch. Dinner would be steaks and roasts and chickens and that kind of stuff. I mean, that's a lot of meat. And if you think about what kind of situations that meat was produced in, I mean, some of that meat these days, you know, when I go places and I buy chickens, I sort of wonder about the conditions under which those chickens were grown. Personally, here's the thing. If I had to go and catch a chicken and kill it and gut it and clean it and cook it and eat it, you know, I'd probably be able to eat about one chicken a week. I'd be happy to eat some cheese enchiladas the rest of the time. So, all right, so this PowerPoint is a done deal. I'm going to shut it off. And I don't know what I did in here, but I guess I'll save it. I guess I did some little modifications in the beginning. So I'm now going to move straight over to this PowerPoint. And you notice again, I don't want to miss the opportunity to mention, you know, oops, let's see, where I'm going to go to the reading view here. Okay, and so here's lecture 12. May 4th, 2020, we're still there this week. I know I will not finish this PowerPoint on biodiversity today. I know I won't, so we'll be picking it up next time. Like it says here, this biodiversity PowerPoint is posted as document number 0019. It's called biodiversity. The rest of this stuff is just the same as we saw before. The topic that this PowerPoint is about is global biodiversity. And we've already talked about the Home Ecosystem Lab, so I'm just going to let people look at that summary sheet, process that summary sheet, and then if you have questions about it, you can ask me about it next time. There's not much really new there, okay? This is just sort of a continuation, though I'm titling it a different lecture and all that. All right, so what this is about is global biodiversity. I'm looking forward to seeing people's summary documents where they talk about PowerPoint, you know, they talk, about biodiversity in their homes. But this is about global biodiversity and some of the, and how powerful biodiversity is. I mean, there's certainly cultural benefits, aesthetic, spiritual, educational, recreational. I mean, I know so many people who, if they can't get out and go and hang out in nature and see plants and animals and all that their life they would consider their life miserable. Of course, global biodiversity contributes to food, fiber products like cotton and wool, fuel, pharmaceuticals. When I say fuel, I don't mean fossil fuels, but I'm talking about fuels like when you burn trees or plants as fuel. Then, oh my gosh, biodiversity has so much to do with ecosystem regulation and support. I mean, really, when you look at an ecosystem, and you know ecosystems pretty well, you know that those are built of organisms. I mean, the biotic part of an ecosystem is essential. The activities that a biotic part of an ecosystem does is, you know, you can't overestimate it. And ecosystems, of course, provide ecosystem services like nutrient cycling, air and water purification, climate regulation, etc. So really, there's different levels of biodiversity. There's genetic biodiversity, there's species biodiversity, and there's ecological biodiversity. So genetic diversity, like it shows here, and we're going to expand on this, is talking about really the variation in genes found in a certain species. So they've tried to show you here that these all seem to be the same kind of fish, but one's yellow, one's orange, one's red. Now, species diversity is really all the different species that make up an ecological community and then ultimately an ecosystem. And then ecological diversity is even bigger than that. It's the variety of habitats, community interactions, the number of biomes that are found on the planet. So genetic diversity, like I said, is the variation in genes among individuals. I mean, look, you want to think about genetic variation, there's lots of ways to do it, but just think about humans. I mean, picture our classroom and picture all the different people in our classroom and realize that their physical bodies are a reflection of their genetics, and their physical bodies vary so much. I mean, there's men and women, there's tall people and short people, there's thin people and heavier people, there's people with blue eyes and brown eyes and green eyes, there's people with blonde hair and black hair and purple hair, there's people who, there's all this variation that is part of the genetic background of an ecological population. I mean, look, I don't personally have genetic variation. It's an ecological population thing. But in the ecological population of humans, right, there is a huge amount of genetic variation. I mean, it wouldn't be impossible for human populations to shrink so low that their genetic variation was much, much less. I mean, I don't think that's what's actually happening. I think the general pattern in humans is that their genetic variation has increased over time, but that's not always true for populations. I know I've talked a little bit about how I study bobcats, and really the stuff that I do on bobcats is I collect bobcat tissues, bobcat poop, for the purpose of extracting DNA and adding to a big population database of DNA. And the reason is so we can get a picture of the genetic variation of Tucson, Arizona's bobcat population. That's what we're interested in. What does the genetic profile, what's the genetic variation look like in the bobcat population that lives in Tucson, Arizona? And the only way to really get that is, under natural conditions, is to get DNA from many, many different individuals and extract that DNA, again, from their bodies, from their poop. I mean, I've stuck a swab inside of a bobcat's mouth and tried to avoid being bitten so that I could get some cheek cells from the lining of its mouth and use those to collect DNA. That DNA then just goes into a big database, and the whole thing is, let's figure out what the genetic variation looks like in bobcats. Why? Well, because as a general rule, when ecological populations start to decline, when they start going from in good, healthy status towards less healthy, maybe even heading toward extinction, you see a huge difference in the genetic variation. It starts to shrink and shrink and shrink. And so it would be nice if we knew what the genetic variation looked like, so that down the line, if we recollected some of that data and we said, wait a minute, the genetic variation is much different. It's changed a lot. We might be able to figure out why and whether that portends potential problems. So genetic diversity, variations in genes among individuals, it's an ecological population thing. Species diversity is really the number of different species that are present in an area. Like, I know I had you looking at biodiversity in your home, but we were really looking at species diversity, right? We were looking and seeing how many different species of plants, animals, bacteria, funguses, I missed one. I feel like, oh, protists we might find in our homes. So we're really looking at the species diversity. And I'm sure there are people who found quite a few species in their homes. And then there's ecological diversity again, the variety of habitats, niches, trophic levels, and community interactions, things that are higher up, ecological interactions. I mean, there are some habitats that are endangered habitats, and that's when we start to lose habitats, then we lose the species that live in them, and we lose the genetic diversity that those species exhibit. So in a certain sense, biodiversity is insurance. It tends to give ecosystems more ecosystem persistent. You know, when you are genetically identical, and that's it, any change can potentially end your, it could drive you into extinction. But genetic diversity confers resistance to change. That genetic variation means that that you may be able to adapt to new environments, etc. I mean, the world is constantly changing. There's, there's things like continental drift that humans have nothing to do with, but it moves continents around. Because of plate tectonics, oceans get created, rivers get created, etc. Okay, so that's one way. But in addition to that, climates can change, and those can alter the habitats of species and cause them to be able to spread into larger areas or be confined to smaller areas. All kinds of possibilities. Hey, how about this? A brand new virus that nobody's even heard of comes out of the forest and suddenly attacks human beings. That is a possibility. I don't know if you've ever thought about it, but the bottom line is that a new virus like that represents a change in the ecosystem that is more likely, it's more likely that we're going to be able to adapt to that if we have diversity in our immune systems, etc. Oh, that's not going to help me. If my immune system is bad, I'm not going to adapt to that virus. But in the human population overall, we're always hoping that there's enough genetic variation that there are people who will survive to continue the human experience, I guess. So let's just think about how many species are there on Earth? Well, right now they think there's about 2 million named species. Now, becoming a named species, it's tricky. In order for a species to become a named species, somebody has to find it in the first place. Then they have to want to study it enough to gather all kinds of data about it. They have to figure out, where it lives, what it looks like, what's the variation in it, etc. Then they have to collect samples of it so they can show it to people who are specialists in classification, so that somebody can say, oh, no, that's a species that we've already counted. It's already on the name list, or it's not on the name list. I mean, honestly, it can take decades to get a species named on the list of species on the planet. Now, how about estimations? Well, people who study biodiversity and study species diversity, they vary a lot. There are some that say that we've named most species. There are other people who say that there's 100 million species. Well, if there was 10 million species, we've only named 2 million of those, then that means that 80% of the species on the planet have not been named and described and officially put into the scientific literature. Of course, if there's 100 million out there, then only 2% have been added into that. Now, 100 million may be pretty high, but you know what? I'm not a bacteriologist or an epidemiologist. I'll bet you there's 1 million species of bacteria alone. But we don't know about those million species. You know why? Because remember what I said, in order for a species to be named, somebody has to find it. They have to care enough about it to try and name it. They have to go through a bunch of rigmarole in order to get it named. And one thing about it, I'll bet you they've named every kind of elephant every kind of wild cat, every kind of bear has probably been named, right? Because these are big charismatic species, you know. But bacteria, I doubt it. I think that when it comes to bacteria, it's hard. They're tiny. It's hard to find them. It's hard to get interested enough in them to study them. I think there's a lot more bacterial species than we see now. Same thing with funguses and with protists. There's more than we know about. And honestly, that makes me think that there's at least 10 million species, and we only know about 20% of those species now in terms of being named. So this is not super important, but when you organize species into hierarchy, you start with kingdom, then you go phylum, class, order, family, genus, species. So, you know, this coyote here, he's in the kingdom Animalia. He's in the phylum Chordata, creatures with a backbone. He's in the class Mammalia, just like you and I. He's in the order Carnivora. He's in the family Canidae. His genus is Canis, and its species, should know this. Species, I think, is something like latrans. So we categorize this way. Hey, humans are in the kingdom Animalia, the phylum Chordata, the class Mammalia, the order Primata, the family Hominidae, the genus Homo, and the species Sapiens. What about cats? My domesticated cats? Kingdom Animalia, phylum Chordata, class Mammalia, order Carnivora, family Felidae, genus Felis, species Catus. You know what? I don't know enough about these to talk very much about anything else from this. But
Mr. Mackey, this is Sydney, the interpreter. I got a little bit lost, and I think I mixed the cats and the dogs and the humans all in their different order. Would you mind giving me the rundown just a smidge slower on those three?
I absolutely would be happy to. So let's go to the coyote. Okay, and I said the coyote was in the kingdom Animalia. It's an animal. It's in the phylum Chordata, which means it has a backbone, a dorsal nerve cord. It's in the class Mammalia, which means it has fur, it has nipples and possible mammary glands. It's warm-blooded. It's in the order Carnivora, like carnivore. That means it eats meat. It's in the family Canidae, Canidae, canids, and then it's in the genus Canis. I think the species is latrans, Latrans. I'm not 100% sure. Now, when it comes to humans, though, notice there's an overlap. We're in the kingdom Animalia. We're in the phylum Chordata. We have a backbone. We're in the class Mammalia. We have hair and mammary glands. I mean, you sometimes ask, well, why do men have nipples? Well, because we're in the class Mammalia, and mammals have nipples. I mean, male cats have nipples. They're not going to ever use them. In the development of their mammalian body, they've developed nipples. Now, humans are not in the order Carnivora. They're in the order Primata, right? The primates. They're in the family Hominidae, Homidae. They're in the genus Homo, and the species is Sapiens, the wise one is what that's supposed to mean. Now, of course, the number one animal on the planet is also in the kingdom Animalia. It's in the phylum Chordata. It's in the class Mammalia. It's in the order Carnivora. It's in the family Felidae, right? The felines. It's in the genus Felis, and it's in the species Catus, right? It used to be, I think it used to be Domesticatus, but now they just say Felis Catus. It's like, sorry, I can't resist. It's like Felix the cat, right? Whoever made up Felix the cat must have seen the scientific name for a cat, which was Felis Catus, and they thought, oh, Felix the cat. Did that help, Cindy?
Yes, thank you.
Did I say Cindy, or I should have said Sydney, but my mouth is starting to work. It stopped to work. I've been doing this all day long. So, all right. So then, oh, and I know this contradicts me a little bit, but then technically these days they've divided the bacteria into two kingdoms, the ancient bacteria and the more modern bacteria. I called all these Monera. And so I did really mean to misinform you, but I've just simplified it a little bit. Then there's the kingdom Protista, the kingdom Fungi, the kingdom Plantae, the kingdom Animalia. So take a look. Of all the organisms on the planet, animals make up the most. Plants make up the second, then funguses, then protists, then bacteria, and archaea, another kind of bacteria. But you know, I think these numbers are skewed in a couple different ways. One is that these things are so tiny that they're not that easy to find. If they, over time, they're going to find a million species of bacteria, I'm sure. Animals have been the most classified because humans have been fascinated with animals, and in fact, they've even been obsessed with animals. And that explains why 73% of the organisms on the planet are animals. But I actually don't think that's completely reflective of reality. I just think it's reflective of the fact that we're animals and we like animals and we want to eat animals and we want to, you know, domesticate them and all that. So a lot of animals have been found, though you're going to be surprised to hear what the most common animals are. Some pictures. So over here, an archaea or bacteria. Over here, a protist, fungi, plantae. Oh no, this actually, you know what? I guess this is supposed to actually represent a bacterium, I think. Well, I don't know. Anyway, fungi, Animalia. This is a protist, good old famous Paramecium, and this is a plant. So, all right, let's talk about animal diversity. 33% of all animals are what? What kind of animal makes up 1/3 of the total animals out there? And I'll bet you people are going to guess this one. Beetles. 33% of all animals that have been named and classified are beetles. You know, I think it's probably because people are really interested in beetles and insects. There are so many different species of beetles, it's amazing. I've been to a beetle museum where they were literally row after row after row after row. I mean, 100 rows of preserved beetles, you know, thousands of species. Okay, so 74% of all animals, I mean, look, we're talking about almost 3/4 of all the animals. What are they? And the answer is insects. 74% of all the animals that have been classified are insects. Now, again, when I see this butterfly, it kind of makes me think about all those amateur lepidopterists, those amateur entomologists that have been collecting insects and preserving them forever and creating giant collections of them. Of course, these insects are yummy, so I'm hoping that for, you know, midnight snack tonight, you'll think about eating some deep fried caterpillars or something. Oh, or that woman was eating what looked to me like a nice toasted tarantula. Now, tarantulas aren't insects. 86% of all animals, I mean, now we're up to 86%. They're arthropods. Arthropods is a phylum, it's phylum Arthropoda. And these are what they sometimes called, well, the name says it. Arthropod means jointed, like arthritis, feet, jointed feet. These are creatures that to a very large degree, if you step on them, they crunch. They have a crunchy exoskeleton. So it includes insects, which includes beetles, spiders, scorpions, crustaceans. Crustaceans, of course, are crabs and shrimp and lobster. You know, what that guy said was true. There's been a time when lobsters were just considered to be disgusting. And now, you know, because they rebranded them, people generally like lobster. Crawdads, crayfish, mud bugs. I mean, these are things that when I was a kid, we used to collect these things and put them in an aquarium. But every time I go to Safeway at Swan and Sunrise, I see a bunch of cooked up crawdads, meaning crayfish. They look like little miniature lobsters. And I know there are people who love them. They tear them apart, they eat the meat, they suck the juice out of the head, et cetera, et cetera. I mean, these things were considered insect-like for a long time. But 86% of all animals are arthropods. That's amazing. So what about 4% of all animals? What are those? Vertebrates. Vertebrates like us. Fish, amphibians, reptiles, birds, mammals. So only 4%. I mean, but these are the ones that have probably been, well, I wouldn't say they've been studied the most because insects have really been well studied. But there's always people studying fish and amphibians and reptiles and birds and mammals, and they only represent about 4%. But in general, these are pretty big, pretty charismatic, pretty interesting, pretty colorful organisms. So what makes up the rest of it? I mean, we've got 86 plus 4. What is the 90? What is the other stuff that's in there? And the answer is there's a number of different animals that you might not even think of. Animals like starfish or octopus or snails or squids or sponges or sea cucumbers, there must be about 10 different phyla of worms. And so the other 90% is made up of a bunch of other phyla that are ones that most people don't know much about whatsoever. So I like this image. This image is designed to show you sort of a picture of all the organisms that have been named on the planet, and the size of the organism is related to how many species have been named. So you can see that when it comes to insects, there's a gigantic insect there because, again, a very large percentage, 74% of all the organisms 74% of all animals are insects. They've certainly been studied better than other organisms. Lots of protists, few amphibians, bacteria, jellyfish. Oh, I didn't even mention jellyfish is another kind of animal, sponges, echinoderms, flatworms, fish, algae, annelid worms, roundworms, etc. Mollusks, there's a snail there. There's quite a few mollusks, and they're less than 10%, right? And then there's arachnids, reptiles, mammals, lots of funguses, really, and, you know, a reasonable number of plants, for sure. So, again, we can take a look at the distribution of species and say, okay, that there's, let's just say fungi, there's 100,000 known species, but there's generally thought there's probably about 1.5 million. Arachnids, those are spiders and mites and scorpions are all in the arachnid group. They've named 102,000 of them, but they think there's about 600,000. Insects, they've named about 1 million known species. They generally think there's about 5 million. Plants, they've named about 310,000 species. They think there's closer to 400,000. Bacteria, look, 7,500, but they positive there's at least 1 million species. Roundworms, this is kind of crazy. These is like some little wiggly worms. There's 25,000 known species, but they think there's probably about 500,000 species. Anyway, the bottom line is that there's lots of species that we don't really know about. All right, so look, this is a good place for me to start, not start. I'm ready to stop, right? It's, this is slide number, what is this slide? Slide 16, no, slide 17. That's where we're going to pick it up on Wednesday, all right? Because we're going to talk about biodiversity worldwide. And so that's slide 17. Okay, and that's where we're going to pick it up on Wednesday night right here. And we'll finish this PowerPoint and start another one, I'm sure. Okay, so I'm just going to go back up through this. I know you're going to want to watch this again and again and again, right? Oh, looks like there's a question. Lisa said good night all, and I bet you that she just disappeared. Okay. Now, okay. So can I answer any questions? Anything that we covered tonight or anytime during the semester, I'd be happy to answer questions if I could. Have you seen those giant hornets? Yeah, I saw a thing about it. I've never seen an actual giant hornet. I mean, wasn't it interesting? They talked about how you can eat those. So if they come out here, let's start eating them. I mean, we'll just eat them and eat them and eat them, and that's how we'll make them go away. No, these things are big and nasty. From what I understand, I mean, if I understood what I saw the other day on TV, was like you get stung by several of those things and it can kill a human. Ooh. That doesn't sound very good, but it's true. I have seen something about that. I'd like to learn more about it. I just haven't had a chance. So thanks for reminding me about that. Maybe I can Google that right now. All right, so look, take a look at these PowerPoints. They're certainly going to help you when it comes to the quizzes. I will have a biodiversity PowerPoint, a biodiversity quiz for next time. So, so you can expect that. I'm still going to continue to shove quizzes at you, even though I am, it's just taking me forever to grade this stuff. I'm going to get it graded, right? Like I said, there was a trickle of stuff this last time, a trickle. There'll continue to be trickle. Believe me, I'm going to have all of this stuff graded before Thanksgiving. That's my goal. No, I have to have all this stuff graded probably by the 20th, and I'm hoping, of course, to have it graded before then so that anybody who has any problems with it can ask me about questions, okay? Oh, gosh, there's a quiz 18 population planning. It's not posted as document number 26. Okay, I got to go back and fix some stuff, okay? All right, everybody, look, stay safe, stay well, stay away from that damn virus, and I'll see you on Wednesday at 5:45, okay? I'll post this as soon as I can.